Welcome to this introduction to Java, one of the world's most popular and enduring programming languages. In this video, we will explore what Java is, how it works, and why millions of developers and Fortune 500 companies rely on it every day. Java's core promise is simple: write once, run anywhere. Let's find out what that means. Java is a high-level, class-based, object-oriented programming language. It was designed to be general-purpose, meaning you can use it to build almost anything from mobile apps to massive enterprise systems. What makes Java special is its platform independence. When you write Java code, it can run on Windows, Mac OS, Linux, Raspberry Pi, and Android, all without changing a single line. This is the WORA Principle: write once, run anywhere. Java's story begins in 1991 when James Gosling and a small team at Sun Microsystems called the Green Team started a project to build software for interactive television. The language was originally called Oak, named after a tree outside Gosling's office. By 1995, it was renamed Java, inspired by Java Coffee, and the first public version was released with the promise of running anywhere. In 2006, Sun open-sourced the Java Virtual Machine, and in 2010, Oracle Corporation acquired Sun and took over Java's development. Today, Java follows a rapid release cycle with a new version every 6 months. To understand Java, you need to know its 3 core components. First, the JDK, the Java Development Kit. This is the full toolkit for writing Java programs. It includes the compiler, documentation tools, and everything a developer needs. Second, the JRE, the Java Runtime Environment. This is for running Java programs, not writing them. It contains the JVM and supporting libraries. Third, the JVM, the Java Virtual Machine. This is the engine that actually executes Java code. It loads, verifies, and runs Bytecode, and it is available on virtually every platform. Let's walk through how Java actually executes your code. Step 1, you write source code and save it as a .java file. Step 2, the Java compiler called JavaC compiles this into bytecode stored in a .class file. Unlike C++, which compiles directly to machine code, Java's bytecode is platform neutral. Step 3, when you run the program, the JVM's class loader loads the bytecode into memory. Step 4, the bytecode verifier checks for any security issues. Step 5, the execution engine runs the code using an interpreter for line-by-line reading and a JIT compiler to speed up frequently used code by converting it to native machine instructions. Java was built around a set of core principles, often called the Java buzzwords. It is simple, removing complex features like explicit pointers that were common in C++. It is object-oriented. Everything in Java is an object, making code modular and reusable. It is robust with strong memory management and automatic garbage collection that eliminates many common programming errors. It delivers high performance through JIT compilation. It is distributed, built for networked, internet-scale systems, and it is secure with a bytecode verifier and security manager that sandbox untrusted code. Java's versatility means it shows up in a remarkable range of domains. Enterprise applications, banks, financial institutions, and large corporations use Java heavily, often with the Spring framework. Android development relied on Java as its primary language for years, and Java is still widely supported today. Web applications are built using Java technologies like Spring Boot and servlets. Big data frameworks like Hadoop are written in Java. Cloud-native applications and microservices frequently use Java, and scientific computing benefits from Java's safety and strong concurrency support. When you learn Java, you gain access to a massive, mature ecosystem. For build automation, Apache Maven and Gradle manage dependencies and compile your projects. For development, IntelliJ IDEA is the most popular IDE, with Eclipse and NetBeans as strong alternatives. The framework landscape is dominated by Spring Boot for building production-ready applications and Hibernate for database interaction. For testing, JUnit and TestNG are the industry standards. This rich ecosystem is one of the main reasons Java remains so dominant in enterprise software development. If you are coming from a C++ background, you will notice some key differences. Java removes direct pointer arithmetic, making memory access much safer, while C++ requires manual memory management with new and delete operators. Java handles this automatically through garbage collection. Java does not support multiple inheritance for classes. Instead, it uses interfaces, avoiding the infamous diamond problem. Java is strictly object-oriented, meaning every function must live inside a class. C++, on the other hand, supports multiple programming paradigms. And while C++ compiles to platform-specific machine code, Java compiles to portable bytecode that runs on any JVM. Congratulations, you have completed the introduction to Java. You now understand what Java is and why it is one of the most popular programming languages in the world. You have seen its history, from Oak in 1991 to today's rapid releases. You understand the three core components: the JDK, the JRE, and the JVM. You know how Java compiles source code into bytecode and executes it through the JVM. You have explored Java's key features, its wide range of applications, its powerful ecosystem, and how it compares to C++. The next step is to set up your development environment and write your very first Java program. Happy coding!